So today I'll be talking about the relationships between pressure, collisions, and volume in real-life scenarios. So the first scenario that I'll be talking about is a suction cup and what happens when a suction cup gets placed on a surface and how it really works. So before I get into the actual examples, I just want to go through two of the relationships. So an increase in pressure, which is also an increase in collisions, causes a decrease in volume. The other relationship I wanted to look at is that a decrease in pressure, which is also a decrease in collisions, causes an increase in volume. So the first example I'm going to be talking about is a suction cup and how that works. So right now you can see in this example the air pressure is equal on both sides coming into hitting the suction cup. So the pressure inside the suction cup and on the outside are equal at the very start. So right here you can see that there's a lever, and when that is pulled, the crease, which is right here, actually moves up, which increases the volume inside the suction cup. And when the volume increases, the pressure inside the suction cup actually decreases, and when the pressure decreases, the amount of collisions also decrease. And that actually makes sense when you think about it, because if the volume is expanding, that means there's more room inside of the suction cup, and the molecules inside of it are moving around with more space, so there's going to be less collisions going on inside. So now that the pressure inside of the suction cup is less than the outside, since it decreased, there is stronger air pressure going on the outside, which is forcing down onto the suction cup. So because there are more collisions going on outside hitting the actual suction cup than on the inside, that is what is creating sort of like a vacuum and forcing the suction cup down onto the surface, which is on the surface. So in order for the suction cup to break free from the surface, the air pressure on the outside of the suction cup actually has to be less than on the inside, and when that is achieved, that is the popping noise you hear when the suction cup releases from the surface, because the air pressure inside of it becomes greater than outside of it. So the next example that we'll be looking at is how does a bell jar work with a balloon inside of it. So right now there's a balloon inside of a bell jar and they have the same pressure, and the first thing that happens is you can see this arrow right here. Air is getting pumped out of the bell jar, and when air gets pumped out of the bell jar, the pressure inside of it actually decreases, which is also a decrease in collisions. So even though the pressure inside the actual balloon itself didn't change, the pressure inside the balloon is greater than the pressure outside of it in the bell jar, because that pressure decreased. So now, since the air pressure inside the bell jar is less than the balloon wants to achieve the same air pressure. So in order for that to happen, the air pressure inside the balloon decreases and the volume actually increases, and when the volume increases in the balloon, that's as it grows and becomes bigger. So as the balloon decreases in pressure and increases in volume, there are less collisions going on inside the balloon because it's actually growing in volume and getting bigger. So the molecules inside of it have more room to move around, and aren't going to be colliding with the walls of the balloon as much. So from here, the balloon will start to grow and grow and grow, and once it achieves the biggest it can become inside the bell jar, it'll explode eventually, and that's due to just not being able to expand anymore. Okay, so I hope those two examples helped your understanding of the relationships between pressure, volume, and collisions. And just to recap, I just wanted to say that this relationship not only applies right here, but I wanted to talk about how it actually applies in the example. So when an example when the volume was increasing was when the balloon was getting bigger, because the pressure inside of it had to decrease to get to the same pressure as outside. So as a result of the balloon increasing in volume, the pressure decreased inside of it, and there were less collisions because there were more room for the molecules to move around. And then in terms of volume decreasing, that was when the suction cup it made the popping noise, because the pressure inside of it, which originally decreased, increased because the volume inside of it decreased as it released from the surface it was on, and achieved less pressure on the outside than on the inside.